All right, so we're going to take some RStudio notes real quick. Well, it won't be that quick because it's kind of long, but so we're going to take some RStudio notes. So when we're doing these, in Unit 6, it's vitally important to our success that we download the pre-lab script. So if you don't remember how to do the pre-lab script, it's Files. I have a lot more stuff in the bottom right of my window than you'll have, but on-ramp scripts, and then pre-lab 6. And here's why. So we know histogram and mean and stuff, but we've got some pretty intricate code here, which I'll get to in a second. But in this code, I don't expect, UT doesn't expect you to be able to run this for loop off the top of your head. So we can just copy and paste this, and then in the notes, I'm going to show you what we need to focus on and what we need to change based on the question that UT asks us. Okay, but we're not there yet, but just warning you, make sure you download the pre-lab, or it's going to be pretty difficult for you, piece of fuzz. Okay, so first question I want to look at is old information. It's from Unit 0 or Unit 1. So is the distribution of calories normal? So basically they want me to check the shape of the population, which is all 100 Karloff people. Well, if we want to check the shape of something, I remember that we want to make a histogram. So I make a histogram. And what do I want a histogram of? All the Karloff people. I want a histogram of their calories. And then we're looking at this, and remember that, Karloff is not technically real world data because there aren't werewolves and vampires running around that I'm aware of. But most of this is going to be real world stuff. So it's not going to be this perfect, symmetrical normal graph. So remember from Unit 1, as long as it's normal-ish, if it's approximately normal. So if it starts low, goes up. Oh, my camera's flipped. If it starts low, goes up, and then comes back down, we're going to call that approximately normal, normal-ish. So this down here, this would be fine. It's not the most normal graph you've ever seen, but it's not obviously skewed in either direction. So we'll just accept this as normal-ish. Just a quick recap, find mean and standard deviation. So if you want to find the mean of something, type the word mean, and then it's data set that you're pulling from, which is all of Karloff right now until I tell you otherwise. And then we want it of the calories variable. Remember that our outputs will show up in the bottom left in the console. So the mean of the Karloff calories variable is 2,400, give or take. So mean, just type the word mean, and then it's data set money sign variable. Histogram, type hist, data set money sign variable. And then standard deviation, we're not going to type standard deviation, it's just SD. But the inside of the parentheses is still Karloff money sign variable. It's still the same format. Okay, so it looks like the mean's around 2,400, and it looks like my standard deviation is around 54. You might be asked that stuff. If it's in the notes, you probably will. So I'm just bringing it back so you remember. It's also in the pre-lab script, but I like to talk about it anyway. All right, so here's where the for, F-O-R, not like the number, F-O-R loop comes into play. I've been coding for a while now, and to be honest, I would struggle to put the for loop in here correctly off the top of my head. So I'm going to copy all of this, all of it. Select lines 13 through 18 on your pre-lab script, all of it, all the way to histogram. And then paste it. Right? If you don't know how to copy and paste, come on, but right click, or Control C, Control V, or Command C, Command V if you got a Mac. So we want all of this. Now, all of this is not going to be exactly the same every time. But 99% of it's the same, and I'll show you what you need to look at to see if you need to change. So this question right here, let me isolate it. Right here, it says draw one sample of size 10. one sample. In the pre-lab script, it says this is drawing 1,000 samples, which is why they have 1,000. So we're just going to change the 1,000 to 1. And why are we going to do that? Because they want me to draw one sample. So I changed the 1,000 to a 1. Okay. It also says one sample of size 10. Well, this is size equals 5. So I don't want size 5, I want size 10. Right here is dataset money sign variable. So in the pre-lab, it looks like we're in the survey data. But right now I'm in Karloff and I'm talking about calories. So I'm going to change this to Karloff money sign calories. Okay. Hopefully you're with me so far. You got to change the how many samples. You got to change the sample size. And then you've got to change your dataset money sign variable to match whatever you're talking about. The last thing we've got to change is at the bottom, it is going to make a histogram. So this is your x-axis, like this is saying between 2 and 10. Well, we're doing calories. Well, the average calories down here is 2,400. And I have a standard deviation of 50. So if I'm only looking between 2 and 10, when I do my histogram, I'm not going to see anything because nobody's eating 3 calories a day, right? So my suggestion would be the mean, make that the middle, and then go a couple standard deviations above and below. So if my mean's, let's say 2,400, well, let's go 100 because standard deviation is about 50. Let's go 100 above and 100 below. So let's do 2,300, 2,500. We'll see if that works. Okay. Now here, make sure you highlight all of it. All of it. Don't run one line at a time. Highlight everything and hit run. Highlight everything and hit run. So again, I picked 2,300 to 500 because I'm going about 2 standard deviations above and below the mean. And I'll show you how to tell if it worked or not. So see how that's not great. It's cut off. So 2,500 is not big enough. So let's raise this to 2,550 and I'll run it again. Oh, I forgot. It's just going to do this because it's one sample. So it doesn't actually matter. So a histogram of one sample is silly. Okay. It's just going to plot one bar. So it's not great. And you can see the mean of my X bar 5, which X bar 5 is my sample. The mean of the population was 2,423. The mean of my sample is right here, and it's 2,419. So remember, there's the population data, which is everybody in Karloff. Then there's my sample, which is what this for loop is going to create, is a sample for me. All right. So that's how you draw a sample of size 10, one sample of size 10 of the Karloff calories. So I'm going to copy and paste this again, because this time and to be clear, because I won't be here, my sample, it pulled 10 random numbers and found the average to be 2,420. Okay. Your neighbor is going to pull 10 random samples and get a different number because you have 100 options. You pull a random 10 out and it takes the average. His RStudio pulls a 10 random out of the 100 population. The other neighbor pulls a different 10. So all your numbers here are going to be different. I mean, there's this 1 in a billion chance that you do get the same number, but it shouldn't happen. It probably won't happen. Which is why when you see the questions they're going to ask in the R homework in the pre-lab aren't actually value specific. They're going to be more conceptual in nature because the actual value that you get there's not a single right, there is no right answer. It's just you pull a random 10 and you take the average and see what you get. Okay, so I copied my for loop that I just ran. But remember, my first loop was one sample, size 10. This is asking 1,000 samples of size 10. So I need to put the 1,000 back. It's basically just saying take 10 random numbers, find the average, find the mean, store it. Take 10 random numbers, find the mean, store it. Take 10 random numbers, find the mean, store it. Do this 1,000 times. So if we were in real life, we would have to find 10 random people, then restart, 10 random people, restart, and we'd have to talk to 10,000 different people. So it'd take us our entire lifetime, and our studio is going to do this in about the next, half a second. We're still doing Karloff calories. We still want size 10. So all we needed to change was the 1,000. So again, we're going to highlight everything, and then we're going to run it. See how this looks more like a histogram because there's not one sample, there's 1,000. And if you look at my X bar 5 now, the first time I ran my size 10, I got 2412. The second time I ran it, I got 2443. The third time I ran it, I got a mean of 2410. The fourth time I ran it, I got a mean of 2420. And I'm not going to read off 1,000 numbers because I can't. But you get the idea, hopefully. So these are the means of every individual sample that RStudio grabbed. Super normal graph, right? That's about as good as it's going to get. And remember, in our central limit theorem from the not coding test last week, the larger the sample, the more normal it becomes. So because I jumped up to 1,000, it should become more normal. And I'm currently at size 10. So if I pull size, let's say size 30, it should become more normal. Emphasis on the word should. There's theories and concepts, and then there's reality. And they are theories or concepts because they hold true the vast majority of the time. But maybe you're the person that you hit it and it's not necessarily true for you. But I just want to increase 1,000 samples to size 30. Okay? To size 30. And if we look, the average of my histogram is right here. That's the two highest bars. And it's between 2,400 and 2,450. So we could say it's 24, 20, 24, 25. And I should have got, quote unquote, 24, 23 for the population. So my sample is to estimate the population. Well, I know the population is 24, 24, let's say. And my sample is between 2,400 and 2,450, a little to the left. So it's probably a little under, probably like 2,418, 2,419 estimating. But in theory, when I go up to size 30, I should, one, get a more normal graph with less variability. And then I should get closer to the actual population mean, again, in theory. So we're going to change size 10 to size 30, but everything else is the same because I still want to draw 1,000 samples. I still want it Karloff calories. I just want the size to be 30. So we're going to highlight everything and we're going to run it. Now, look how it is. And I can go back. So if I go back here, we go from 23, we'll call it 2375 to 2575. So we've got a range of about, or 24, about 100. We've got a range of about 100. And it's a little more variable. And here we go from 2,400 to 2,450. And the middle is dead on 2,425, which is basically what I want. So we've got closer to the mean, like the actual estimate. The high bar in the middle is exactly the population mean, pretty much. We're way less variable. So we started with 100 from end to end, and now we're barely at 50. Okay, so that's what it means by less variable. So it becomes more normal, so taller, and then it becomes more narrow or skinny because it's less variable. Okay, so we're done with the for loop stuff. So when it asks you to draw a sample, you copy and paste from the pre-lab. This does not have to come from your brain. And these numbers right here are how many samples you want. So if they say 1 sample, 10 samples, 100 samples, 1,000,000 samples, just change this number. This is the size of your sample, which is why it says size equals. Sometimes they might say n equals like 15 or something, but n is sample size. This is data set money sign variable. So here I'm looking at Karloff calories. Whatever you're looking at goes here. And then these are the range of your x-axis. How did I pick 2300 to 2550? I saw a mean of about 2400 and a standard deviation of about 50. So I took 2 standard deviations. So 50 times 2 is 100. Right? I doubled the standard deviation and I added and subtracted that, give or take, both ways. And that should be enough. If you want a wider range, it's fine. You'll just have a wider range and it'll be smaller. If you run it and you're like, man, I should have picked different numbers, just run it again with different numbers. Nobody's going to know. Okay, so that's how you run the for loop to find samples. The bottom two are how do we find standard error in RStudio, and conceptually, what does standard error, like how do we use this? So expected standard error, how do we find it? First off, on your formula sheet or in your notes, it's standard deviation divided by the square root of sample size. So it's standard deviation divided by the square root of n. Well, so if the standard deviation is, if n equals 10, so if sample size equals 10, my standard deviation is right here, right? My standard deviation is right there. So I've copied it. To find standard error, you would do standard deviation divided by square root of n. And square root is SQRT, parentheses. So standard deviation divided by the square root of 10 takes me here. And it tells me that my standard error for sample size 10 is 17. Now, for sample size 10, I expected it to be 17.27. If I go up here to my actual sample size 10 and find the standard deviation, so if I run a sample of size 10 and I find the standard deviation of x bar 5, which is what I called it, you call it Jimmy if you want, it doesn't matter. And I like when you highlight it, it'll put everything in a box and it'll show you. But I called it x bar 5. So if I take the standard deviation, I expect the standard deviation to be 17.3. My actual sample, I got 16.4. But it's a sample, right? So every time we run this, we'll get a slightly different answer. Slightly. So expected and actual are different. If it asks expected, it wants you to use the formula from the formula sheet. It talks about actual of your sample, go up here. So n equals 30. Well, it's standard deviation divided by square root of n. So it's 54 divided by square root of 30. And before I press enter, it asks me, do I think it will be more or less than n equals 10? Well, the larger the sample size, the more normal it becomes. The more normal it becomes, the less variable it becomes. So see here I had a range of 100. Here I have a range of 50. So I expect my standard error for 30 to be smaller than my standard error for 10. And it went from 16 to 10. So it's significantly smaller. Okay. That's all I got. I know this is code looks kind of complicated, but you've got to use the pre-lab script and then you just copy and paste lines 13 through 18. I don't expect this to come off the top of your head. So use the pre-lab, copy and paste lines 13 through 18, and then you just need to change the values to be what you want. Okay? I'm at home taking care of my son. So if you have a question, you can just send me a message on Remind or send me an email, and I'll get back to you if I have my phone next to me. But hopefully with this video, we can do our homework. So good luck.